So now that we have understood how we calculate cofactors, let's quickly move on to understand what is called as Laplace's expansion. Laplace's expansion tells us that a determinant can be expanded in terms of any row or any column by multiplying each element of that particular row or of that particular column that we have chosen by its cofactor, that is multiplying every element by its cofactor and then adding up all those terms. Let's see, suppose I want to calculate the determinant of third order here. The elements of this determinant are a1, b1, c1, a2, b2, c2 and a3, b3, c3. Now say by Laplace's expansion, we can find out the value of this determinant by choosing any row or any column of our choice. Let's say I want to calculate the value of this determinant by expanding by R2. Now what do I mean by expanding by R2? I mean to say that we are going to choose the elements here in second row. What are the elements in second row? A2, B2 and C2. Isn't it? So to calculate the determinant, what we do is we multiply every element of this second row, that is A2, with their corresponding cofactors, that is A2 into the cofactor of A2, B2 times the cofactor of B2, C2 times the cofactor of C2, and then we add up those terms. That is, this delta or the value of this determinant will be A2 into cofactor of A2 plus B2 into cofactor of B2 plus C2 into cofactor of C2. What is cofactor of A2? This is in the second row first column, so it should carry a negative sign, so it is minus A2 into cofactor of A2 will be B1, C1, B3, C3. Imagine that you are deleting this second row and the first column where A2 lies. The remaining elements will be B1, C1, B3, C3. Isn't it? Similarly, plus B2, plus because this is in second row second column, so this carries a positive sign, and this cofactor will be the determinant of A1 C1 A3 C3 minus C2 into A1 B1 A3 B3. Okay, you can also calculate the value of this determinant by expanding by columns. Say if I want to expand this particular determinant by third column, now what are the elements in the third column? C1, C2 and C3, isn't it? So we will be taking C1 into cofactor of C1, C2 into cofactor of C2, C3 multiplied by cofactor of C3, and then we'll add up those terms. So delta or the value of this determinant must be C1 into cofactor of C1 plus C2 into cofactor of C2 plus C3 into cofactor of C3. What is cofactors of C1, C2 and C3? C1 will be A2, B2, A3, B3. C2, because this is in second row third column, this carries a negative sign, so this will be minus C2 into A1, B1, A3, B3 plus C3 into A1, B1, A2, B2 determinants. Let's quickly look at an example. Suppose I want to find out the value of this determinant of third order with these entries 1, 0, minus 1, 3, 2, minus 3, 1, 7, minus 2. Now here, as I told you, we can find out the value of determinant by choosing any row or any column of our choice. And how do we usually do that? We usually look at those rows or those columns where the values, where the numbers are smaller, or if it has a 0, then that's an added advantage. So here in this case, I have elements in the first row are 1, 0, minus 1. There's a 0 here. So for the simplicity or for the ease of calculations, we can expand this determinant by choosing R1, or you can also expand this determinant by choosing this C2. Let's see both the cases. Say we want to expand by R1. When we say expand by R1, what we mean? We take every element of R1, that is 1, 0 and minus 1, multiply this with their cofactors, that is 1 into cofactor of 1, 0 into cofactor of 0, minus 1 into cofactor of minus 1. Now 0 into anything is anyway 0, so what we have is 1 into cofactor of 1 and minus 1 into cofactor of minus 1. So what is cofactor of 1 and minus 1? That should be 2, minus 3, 7 and minus 2, minus 1 into, this is 3, 2, 1, 7. And when you expand these determinants, you find that the value of this determinant is -2. Similarly, if we want to expand by second column, what we do? We take elements in the second column, 0 into cofactor of 0 plus 2 into cofactor of 2 plus 7 into cofactor of 7. 0 into anything is anyway 0, so what we have is 2 into cofactor of 2 plus 7 into cofactor of 7. And what should this give you? This will also give you -2. So you see, you can expand the determinant by anything, by any row or by any column, still you get the same value. That is, the value of the determinant will remain same. Okay, let's also look at an example where we want to find out the value of the determinant of a fourth order matrix or a 4 by 4 matrix. Now here again, in this matrix, as you can see, we have zeros here. Now this second row has 2 zeros. Similarly, second column also has 2 zeros. So it's easier if we expand by this. But then you can also verify the result by expanding the determinant by choosing any row or any other column of your choice. But for the simplicity, we will be using this either second row or second column because this has 2 zeros here, isn't it? So let me say I want to expand by R2. Now what are elements in R2? 1, 0, 3, 0. So by Laplace's expansion, it must be 1 into determinant cofactor of 1 plus 0 plus 3 into cofactor of 3 plus 0. Now what is cofactor of 1? Is again a determinant of third order. That is, imagine that you are deleting this particular row and this particular column where it lies. It will be 1, 2, 3, 3, 0, 1 and 0, 1, 2. And 3. Now this, the signs here, mind you the signs, this is negative sign here, this also carries a negative sign. This is in second row first column, this is in second row third column, both carry a negative sign. So this will give you this determinants of third order here, -3 into determinant of third order here. This will be 0, 1, 3, 2, 3, 1 and 3, 0, 2 plus 0. Okay, so let's expand these determinants again. You can again choose any row or any column to expand these determinants. I have chosen to expand by C1 in this case and by R1 in this case, and I have obtained the result as 88. So you can verify this result by expanding the determinant by any other row or any other column of your choice. Still you will get the same answer, 88.